Good morning. Take a look at the joke of the day. Silly con. Anyway, today we're going to go over the homework, which is the last part of the sheet on the packet. And I'm not really going to give notes on the organic reactions. That's really going to be your homework tonight. And I'll post those pages, although you should have your Regents Review book. And then I'm also going to be posting the test for this particular chapter, this unit. And that's going to be due Friday by 3:15. Okay? As long as I'm talking about it, the notes on the organic reactions, they're in your Regents Review book. Make sure when you do those that you give examples of each reaction. Okay? Give examples of each reaction. And then wherever you put them on your paper, lined paper, I would assume, take a picture of that and then submit it. Okay? All right, so let's take a look at the homework. And I don't know if you picked up an error that there was there, but there was. Okay, so I wanted you to do the last 6 of these. So this, starting with number 9, 3-chloroheptanoic acid. Okay, so the oic acid tells me that it is an organic acid. The hept part tells me that there are 7 carbons. So I'm going to go ahead and start with that. 1, 2, 3, 4, 5, 6, 7. And when I'm naming these, I include the carbon that's part of the carboxylic acid group. And remember that this takes number 1. This is the number 1 carbon. So I'm going to go backwards with my naming or numbering. 1, 2, 3, 4, 5, 6, 7. So there's my heptanoic acid. And number 3 is the chloro. So 1, 2, 3. So there's 3-chloroheptanoic acid. Just make sure you have enough lines around each carbon. Each carbon can make 4 bonds and has to make 4 bonds. Okay, number 10, cyclopentene. We didn't do a cyclo one in a while, but cyclo means that it is in a ring. It's an aromatic compound. The pent tells me that it has 5 in the ring, so I'm drawing a pentagram. 1, 2, 3, 4, 5. And the ene on it tells me that I've got to, I'm making it a double bond somewhere. So it doesn't tell me where, so it doesn't really matter. So there's my cyclopentene. Okay? If it said 1, 3 cyclopentene 1, 3, then that would mean that it would have 2 double bonds. It would probably be a diene. We're probably not going to have to worry about that at all. So cyclopentene is an aromatic compound with 5 carbons, 2, 3, 4, 5, and 1 double bond. All right, number 11, methanoic acid. Okay, so meth is 1 carbon, and oic acid means that it's got the carboxylic acid group, and since it's only methane, I'm done. As long as this carbon has 4 bonds, 1, 2, 3, 4, and it does. So there's methanoic acid. Number 12, 2-methylbutanol. Okay, so Al tells me it's going to have an aldehyde group at the end. The but tells me that there are 4. So 1, 2, 3, 4. and then the Al group is going to be at the end. So the aldehydes have this, they have a carbonyl group and then just a hydrogen, compared to the carboxylic acid, which looks similar. Both of them are at the end, but the aldehyde does not have that oxygen. So what else do I have here? It's 2-methyl-butanal, 1, 2, 3, 4. And this is my first carbon, so 1, 2. And methyl. 4 bonds around each. Should be all set. So 2-methyl-butanal. Number 13. 2-chloro-3-pentanone. Okay, the one tells me that it's a ketone. And a ketone has a carbonyl group in the middle somewhere. Alright, so the pent tells me there are 5. 1, 2, 3, 4, 5. The 3 tells me that's where the carbonyl group is. There's the third. And 2-chloro, I could use either one of these because I could count since this is right in the middle. So I can put it here, or I could put it here, or here, or here. Alright? So as long as it's on one of these 2 carbons, it should be it. 2-chloro-3-pentanone. Alright. And lastly, methyl ethyl ether. This is where the error is. It really should be ethyl methyl ether, because when we do ethers, the naming of them goes alphabetical. So that's my fault. So ethyl methyl ether, then ethyl, and then the methyl. Now remember that ethers, there's an oxygen in the middle, and there are R groups. You'll see it written like this. The R groups are the carbon chains on one side and the other. All right? So methyl ethyl ether. Now, it's worded ethyl methyl ether. That's what it's supposed to be. But it doesn't really matter. You can put them on either side since it's this type of situation. It's kind of like this, drawn like this. It's the same molecule, I'm just flipping it around. Okay, let me just draw this quick. This is ethanol. So right here I've drawn it like that, but remember these are molecules, so they're constantly moving. You could draw it like that, okay? You can't change the bonding around, but this drawn like this, it's the same molecule. Okay, so I just need to put an ethyl on one side and a methyl on the other. That's it. 1, 2, 3. Make sure each of the carbons has 4. So here's my methyl group, here's my ethyl group. Again, the same thing. So this could be flipped over like that, and then the methyl would be over there. It doesn't really matter. In fact, you could draw it like that if you wanted. This is being stubborn. Okay, so there's your ethyl methyl ether. All right? So, I'm not going to give notes really on the organic reactions. The notes are in your Regents Review book. And I just thought about it. You haven't had to take notes of your own really ever in here. So it'll be a good practice. Probably should have done more of it, but it's not how I did it. So test is going to be due Friday by 3:15. I'm going to post it today. So today's Tuesday. It gives you plenty of time. Tomorrow, I'll probably make a short video on the organic reactions just to highlight them. I do have notes, but I did not send them home with you. So we'll probably do that, and then Wednesday we'll do a little review, and then Thursday we'll probably start the new unit on the nuclear chemistry. Okay? So, pretty short today. Spend your time doing some good notes on organic reactions, and I will see you tomorrow.